4th graders, today we're doing Module 5, Lesson 4, just continuing right along, and we're still talking about decomposing or breaking fractions apart. But today what we're doing is we're going to decompose fractions into sums of smaller units, of smaller fractions. So we're saying 1/2, if I have 1/2, could I cut it into smaller pieces? Yeah, if I had a cake and I only gave you half, but then I cut that half into another half, how big would one piece be? Say it out loud if you know. 1/4. 1/4. Good. So can I say that 1/2 is equal to 1/4 plus 1/4? Do you guys agree? Right? What I just did was I decomposed that fraction, 1/2, into a sum of smaller units. A fourth is smaller than a half. So that's what we're doing today. Make sense? But first let's talk about the problem of the day. Since today we're talking about decomposing something into smaller sized units, we need to talk about how you can tell if a unit is bigger or smaller than it, okay? Which one is bigger, 1/2 or 1/3? Everyone?
1/2.
1/2, okay. Because if I have a whole pie and I cut it into 2 pieces, that one piece is going to be bigger than if I were to cut the whole pie into 3 pieces. Do you guys agree? Okay, good. Let me ask you another question. Which one is bigger? This guy. 2/3 or 1/3? Everyone?
2/3.
Okay, because obviously 2 of something is bigger. Which one's bigger? 1/25 or 1/3?
1/3.
1/3, okay. Which one's bigger? 1/12 or 1/3?
1/3.
1/3. Which one is bigger? 1/12 or 1/5?
1/5.
How can you tell if a unit is bigger? If the denominator is bigger, that means that the unit is smaller. Good. Okay, so I want you to keep that in mind. Today we're going to be taking fractions and decomposing them, breaking them apart into smaller sized pieces. When I break something into a smaller sized piece, for example, from 1/2 into 1/4, the denominator changes from 2 to 4. So it's opposite. Usually 4 is a bigger number than 2. But in the case of fractions, when the denominator is a bigger number, it actually means that piece or that unit size is smaller. Good. That was a good review. I just want to make sure you know. Okay. Please. Here we go. Go ahead and draw that top tape diagram. You can see I have one hole, and I've divided it into 3 equal sized pieces, which means my unit is what? Thirds. Good. What fraction is shown by the shaded portion there? Everyone? 1/3. Okay. Now, what I did down below, and you can go ahead and do this right on your own tape diagram too, is I cut each third into smaller sized pieces. I cut each third into half. Do you see that? So now how many size pieces are there? Same equal size pieces are there? Everyone? 6. Which means this section right here is 1/6, right? Now, if I shade in still 1/3, how many 6 are shaded in? Everyone? 2 6. So what this shows is that 1/3 is equal to what? 2 6. Good. So I can say that 1/3 is equal to 1/6 plus 1/6. Do you guys agree? Or as a multiplication sentence, it's equal to 2 copies of 1/6. Let me remind myself what I put here. Okay, we can also show this using a number bond. We can show that 1/3 is equal to 1/6 plus 1/6. Or 1/3 is equal to 1/6 plus 1/6, or 2 copies of 1/6. Or if we write it as one fraction, it's equal to 2/6. You guys see that? Go ahead and take some complete notes. So what this tape diagram shows is I can decompose 1/3 to be equal to the sum of 2 smaller unit fractions, 1/6 plus 1/6. You guys agree? Good. Can you guys still see, using the black lines here, that 1/3 of the entire piece of tape is shaded in, right? Okay, good. Now, when I divided it using the blue lines, we divided it into what size units? 6. Now what I've done is I've used red lines to even further decompose it. Now one blue section has been turned into 2 red sections. How many red sections are there altogether? Draw the tape diagram and then count how many, what size units are in red. There are 12 red units, which means that 1/6, remember 1/6 was the blue part, how many 12ths are there in 1/6? Look at your drawing, how many 12ths are there in 1/6? Everyone, show me with your fingers. 2. That means that 1/6 is equal to 1/12 plus 1/12. We've decomposed the fraction of 1/6 and rewritten it as the sum of 2 smaller sized unit fractions. How can I write that using a multiplication sentence? It's 2 copies of 1/12. Good. Now let's go back to the third, 1/3, because that's what's shaded in. How can I write 1/3 as the sum of 12ths? How many 12ths are in 1/3? Show me with your fingers. 4. So I can write that 1/3 equals 1/12 plus 1/12 plus 1/12 plus 1/12. I could also, since it's repeated addition, I could also write that as multiplication. How could I express that addition sentence as multiplication? Eyelet?
You can do 4 times 1/12.
4 times 1/12. Very good. So again, we've now decomposed 2 fractions, 6ths and thirds, into a sum of smaller unit fractions, in this case, 12ths. So in both of these tape diagrams, 1/4 is shaded in, but the problem is asking us to decompose it as the sum of smaller unit fractions in 2 different ways, as shown in the picture. So let's look at this first picture first. 1/4 is shaded in, but it's decomposed into smaller sized units. What size is the unit that it's decomposed in? Go ahead and draw the tape diagram and see if you can label each of those smaller sized sections. I can see that there are 8 sections, 1, 2, 3, 4, 5, 6, 7, 8, which means that the unit must be 1/8, right? So this part here is 1/8, and this part here is 1/8. So what that means is 1/4 is equal to 1/8 plus 1/8. That's one way to decompose 1/4. But there's another way, well, there's many other ways, but we're going to do at least one other way. Let's take a look at this example here. The same 1/4 has been shaded in, but it's decomposed now in a different way. The 1/4 has been divided into 4 smaller sized sections. So what is the size of the unit here? Take a look. The one whole tape diagram is divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16 equal sized sections, which means my unit must be 1/16. Good. So here, this part is 1/16, this part is 1/16, this part is 1/16, and this part is 1/16. So I can also show that 1/4 can be decomposed into 1/16 plus 1/16 plus 1/16 plus 1/16. Do you guys agree? So we've shown 2 different ways to decompose 1/4. We can show that it's the sum of 4/16 or the sum of 2/8.